In this experiment, we will learn about how to choose a suitable fuse to protect a circuit. Your teacher will set up a circuit with a 0.2A fuse as shown. Switch on the power supply. Slowly increase the current through the circuit. The light bulb first becomes brighter and then suddenly goes out. What is the ammeter reading just before the light bulb goes out? Does the fuse burn out? Your teacher will then connect the bulb to the power supply set at a low voltage. Does the bulb light up? Has the bulb been damaged? Now, repeat the experiment with a 2A fuse. What is the ammeter reading just before the light bulb goes out? Does the fuse burn out? Has the bulb been damaged? In this experiment, when a 0.2A fuse is used, the fuse burns out when the current is larger than a 0.2A. This breaks the circuit so that the bulb is not damaged by the larger current. Hence, when the bulb is connected to the power supply set at a low voltage, it lights up again. When a 2A fuse is used, the bulb goes out when the current is 0.8A. When the bulb is connected to the power supply set at a low voltage, it does not light up again. This shows that the bulb is damaged, and the maximum current that the bulb can withstand is 0.8A. As a 2A fuse can withstand a larger current, the fuse does not burn out even when the current is larger than the maximum current that the bulb can withstand. Therefore, the bulb is damaged by the large current.